So, like I mentioned, we are back to Unit 3 again. We're going to be doing a quick recap of some of the things we already did in previous classes, and then I'm going to zero in on a couple of other concepts that we didn't really talk so much about, and then I will introduce us to one last section of the discussion that will be today, some of the things we haven't discussed at all in the class. Then soon after that, we're going to proceed with the bouncy ball app, and that would be after the break. So I'm going to share my screen right now, and we're going to proceed. Again, feel free to stop me, feel free to speak up, just unmute and talk, or if you prefer to raise your hands, do raise your hands. If you prefer to type in the chat, feel free to do the same. But the good thing is when we'll start working on the lab, the bouncy ball app, I'm going to be referring to some of the concepts I'm going to talk about here right in the code section of this, so that you can see the application of some of the things we're mentioning here, which is, by the way, the whole purpose of developing the theoretical framework, so that you get into the lab really having an in-depth understanding of what you're doing and why you're doing them. All right. I'm going to share my screen, and how do I share here? So, window screen, let me go to window. Okay, so that would be me here. Let's see. There's some sound. Just a minute. Okay, so this is slide unit 3. We're working on unit 3, organizing data. In previous classes, I talked about things around the knowledge we intend to acquire, the various applications of what we want to do. And then, of course, I talked to us about different types, or types, TYPES. It's just types, right? Types within Swift. And we mentioned that there are different kinds of types. And we talked about the user-defined types. A lot of these we've already talked about within the class in one or two of the previous units, right? We talked about things like strings, integers, arrays, dictionaries, and character. I think what we haven't talked about is options, that I'm gonna, I think it's not explicitly discussed in the book, but at some point I'm going to mention it and probably walk us through what options are. And then you have the compound types. And the compound types are referred to as compound because what's happening is they are like big warehouses, right? Or they are like warehouses where some of these primary types are warehoused, right? In different combinations to be able to achieve certain purposes. And then you also have the user-defined types, which are mostly types that, user-defined types here, which are mostly types that are created by users. 2 or 3 of those that we're going to talk a whole lot about in this slide will be the class structures and enumerations. Protocols and options are things we would revisit sometime in the future. But the very ones I just mentioned now are actually probably the most important. So what I've done is I've decided to classify the 2 classifications, which will be the user types and the standard libraries, right? In the the standard libraries and the compound types, right? I've kind of tried to put them together in one group that I will refer to as types or types 1, right? Like a section of one, and those are the areas I'm going to discuss. And then eventually we're going to come to look at a different category of types down in this later in the class. So one of the things I mentioned was the idea of collections, right? And there are a couple of types that we generally refer to as collections. And we call them collections because they are a collection, they are used for storing collections of values, So we can put together a bunch of values and then we can store them in this, and that's why we refer to them as collections. And what I had mentioned the last time was that a collection is a sequence, right, that has a couple of elements, and that these elements can be transversed. In other words, you can run an operation through those elements multiple times in a very non-destructive manner, and then that they can also be accessed by indexes, pretty much like saying that you have a neighborhood, a bunch of people living within a neighborhood, right? That the houses are organized in a sequence, and then you can actually drive through all of those houses without destroying any one of them because of the way they are arranged. And then that each of those houses have addresses. That's literally what this definition is talking about. And I gave us the last time an example of a typical collection, because the collections, like we mentioned, are actually like there are types, and you have like the book literally refers to arrays, sets, and dictionaries. So if you go back to the types diagram, you probably wouldn't see sets. Sets are also a type, so still consider them as a type. But it wasn't probably, I didn't probably include it there because the sets are literally like arrays. It's just a few differences between them, but they are literally also types. So that's an arrangement we have here, and I just laid out a particular example of, say, arrays, right, where you have Ben, Mary, Hilda, Philip, and all of that. And then the other thing I mentioned was that the indexing, indexing method of computers, right? They run or store things, right, in the decimal system where you actually begin to count from 0. 0 to 9 is 10, right? 0 to 9, because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you complete one set of 10, and then you change your count and start from 10 to 19 is another set of 10. And that's how the computer actually stores elements within collections or arrays in this particular case. So you have a bunch of these. So if I'm looking for the address of these, this is 0, 1, 2, 3, 4, 5. So which is what we have here. So if I were to write a code like this, which I hope you would have done by this time, I create an array of these persons with their names, and then I want to access, say, person in address 0, that would be Ben, and that's why we have an output of Ben here. And if I want to look for a person in this address 4, all I need to do is count 0, 1, 2, 3, 4, and that's why we have Johnson here. So there are a couple different kinds of collections, right? And 3 of the primary, we'll call them the 3 main collection types. And if you've gone through the book, right, those are the types that are mainly discussed, right? Arrays, sets, and dictionaries. But then that's not all. You also have tuples. And tuples are not considered one of the 3 main collection types, right? Because they are a bit more like, if you go up to the types, one of the things you're going to see is where we talked about tuples as being compound types, right? So they serve a larger purpose, as it were. Even though they are collections, but they are used to group together multiple values of different types into a single compound type. So literally, when you have a tuple, you can literally have different combinations of types. Like you can have a dictionary inside a tuple. You can have an array inside a tuple. So think of it from my description the last time I talked about this, it's like a U-Haul truck. And then behind it, you have all these other boxes that you've put together. Consider these, for example, different boxes. Your box of orange, box of metals, and box of some breakable china, right? And you could actually bring some of them and put them behind the trunk of a U-Haul to help you carry all of that. So, and then the other thing I mentioned the last time was the issue of whether collections, right, are ordered or not ordered. So, and I did mention that arrays, for example, are ordered collections, but all the other tuples are actually unordered. And I went on to discuss what it meant for a collection to be ordered or unordered. So these are characteristics of ordered items, but let me just use this piece of code as an illustration. So here, what I'm doing here is I've created this for student ID array, right? And I explicitly define this to be an array because I don't want any confusion because you have set an array here. So I've explicitly defined it as an array. And then I have my student set here. Notice that both of them have the same elements within them, right? Now, what makes it an ordered array is whenever I use, I try to use a specific collection like an array which is ordered, the elements are never going to change because they have specific locations and addresses. So they are not changing, right? It's unordered. And I think the example I gave the last time was the whole example of having two types of offices. One of their offices is everybody has a specific desk where they can sit. And the other office is whoever comes first takes whatever seats they find comfortable, right? Same thing like getting on a plane, and in one airline, you have a seat assigned, and the other airlines is just come on and show up. So if you were to have 100 people get into the airplane where there are no assigned seats, you probably would have between 90 and 100 permutations or arrangements of how people sit. That's what happens with unordered pairs, right? So what I have here is array gives me exactly what I have here. The elements are not altered. But look at set, right? All of a sudden, the elements are changed. Now, the magic of this is if I decide to run this code again, I'm still going to get my arrays arranged in this fashion. But my sets will probably not have 115 sitting here. It might be 114 because it's an unordered array. So they do not have a defined order, talking about the elements. They can appear in different order every time they are used, talking about the elements. Cannot be referred to by index or key. So if I want to figure out the location of any of the elements, the indexing thing that I talked about there wouldn't work. So, and I start by talking about arrays, ordered collection of values. I'm going to keep moving it fast. And then this is me trying to explicitly define an array, colon array equals to this, and I have, specific feature of an array, block brackets, and then you have your commas after each item or element. That's what literally an array is. And the other thing is it has to be the same value can appear in any array multiple times at different positions. So I can have 78 5 times and they are going to appear as is. And then the other thing about arrays, it has to be the same type of data in an array. You don't vary data, it's the same type of data. So if I write 100 here and then I come on here and include a string, pen is going to give me an error because that's not what an array does. Arrays are used to store one type of data. So this is an example of you creating an array. So notice this, arrays are used to hold elements of the same type. So this is an integer. These are all integers. These are strings. Notice that they are all strings. And these are doubles. Notice that they are all the double type. This is more so like the example we talked about earlier, where each element in the array has a specific address. And then I talked about methods the last time, right? There are several kinds of methods in Swift for arrays. And I think I included that in the slide where, for example, this is an example of an array. And then this is a syntax. And what I had suggested to was, so these are some arrays in some methods in array, right? Remember that array is a type, and most types have properties and methods. Methods, talks about the behavior of that type, right? So even if I don't know how to use an append, I could just go type append in Swift and then ask for the syntax. And then if I ask for syntax, it's probably give me something like this. And this literally tells me, hey, I can insert an element, right? And here it's asking me, I can insert a new element. But then, comma, I also need to provide where the index of that new element. Since you have all elements have fixed locations within the array, if I'm going to insert something, I need to be able to tell the system, I want this to go into address number this, which is what is going on here. So I've created these var even numbers 2, 3, 4, or 2, 4, 6, 8, 12. But I remembered, oh my God, I'm supposed to have 10 here, right? So how do I insert that? So I use my insert method, even numbers dot insert. What do I want to insert? Which is the new element I want to insert? It's a 10. At what location? I choose 4. Why am I choosing 4? Because this is 0, 1, 2, 3. I need to put it next 4 before this, right? So if I do that, I'm going to get this output. So 10 has taken a pride of place within the even numbers, So these are methods you can check, and practice with them. They do all kinds of things. Again, methods are a way. And in the later part of today's class, I'm going to be talking to us about the difference between methods and functions. For starters, methods are functions, but there's some kind of difference between methods and other functions. And we're going to talk about that a little bit. That's the part I haven't gotten into yet. Excuse me. So, and then we talk about sets. Sets, right, are literally like arrays. In almost every way, they are arrays. The only difference is some of the things I mentioned. A set is a collection of unique data, same thing as arrays. The only main difference is that elements of a set cannot be duplicated. In other words, I can't have, if this was an, okay, for this array, I can have 112, 112. But for sets, if you have 112, 112, at the end of the day, it's going to eliminate one of the 12s and gives you only 112. Array keeps everything. That's the fundamental difference between array. These were examples that I gave the last time. And then just like arrays, sets also, have methods. And look at the insert for set, right? Just ask for the new element. Why doesn't it have the index, the addressing location? Because because it doesn't care about indexing. It doesn't care about, it doesn't really care, it doesn't really care about the location of the new elements. The new element can go anywhere, which is where we gave this as an example, right? We're talking about colleges in South Carolina. We have all of this in a set. The following are the colleges in South Carolina. So assume you have a set that has everybody entering their colleges, and there are like 5,000 entries because students from all of the places are entering. But then you have these, say, 5,000 entries, and all you're really interested in is, I want to know all the number of schools, the unique number of schools, names of the unique schools, right? That's where you use sets. Set is going to reduce the duplication and just give you one for each of the schools. But then in this place, we are trying to insert Benedict College because Benedict doesn't appear. And then what do? All we do is dot insert, and then we include the new element as shown here, right? And then once you run it, all of a sudden Benedict has been included here. The following are colleges in, this was the first reading, and then when you inserted, you now got this. So that's where we are for this. And then these are methods, examples of methods also for sets. And that's what takes us to dictionaries. And when I discuss dictionaries, I talk to us about thinking about dictionaries, right? Whenever you hear dictionary in programming, it's thoughtful. It makes sense to begin to think about the dictionary you have in your house, on your table, or elsewhere, right? Because dictionary is about matching pairs of things. You give me a word and I give you the meaning. It's almost, think of the forms that you have to fill out every day when you go to the doctors or you go to a college to register for a class. They give you this form, it gives you a bunch of things, and then you provide responses. That's literally what dictionaries are. So it's an unordered collection of elements or items. So in the case of dictionaries, they're also unordered. They store elements in key pair values, and then keys are unique identifiers associated with the value. So there's a connection between the key and the value. So this right here is an example. Notice how this is written, right? You do your dictionary, same thing, like almost like it's an array, but then the difference is the way you present the data internally. It's Samuel is linked to rice. Okay, maybe Samuel likes rice, right? Susan likes spaghetti. Karen likes pasta. So how do we represent it? We do something like this, right? So I said var favorite food, and I list my elements within my key value pairs, and then I print out and it gives me this. Same thing here. I can actually associate two different data types in dictionary, where I have one here, an integer and a string, integer and a string, integer and a string. And if I print this out and I get this. So you also go through this. This is another example. I talked, this is an example where I'm trying to match first name, last name, age, height, and all of that. How do I store that? I also try to store that with a dictionary. So all of those examples, and then dictionaries also have methods because they are a type, right? And this is an example of enumerate, right? Or enumerated. And then let me show you how that's used here. I'm trying to store someone's date of birth and their date of death, born 1909, died 2002. So if I want to use enumerated, right, because it just helps you run through. So watch this. For index, we already know what our index is, right, and the key value pair. In information.enumerated, that's my information and that's my method, right? So for this, in this, when you print this out, it's just going to give you the index and the key value pair, right? That's how it's going to print it out. So this is an example of its active use here, where you have this class grade, Steven's class grade is this, Sarah's class grade is this, Ali, and all of them. So I want to print everything, you know, I want to loop through all of the elements within a dictionary. And that's where I begin to use my enumerated, right? And I use the for statement for, remember, this is always a key value pair. So that's my key and that's my value, right? So I go to this in for each of these, for each of the key value pairs, right? For each of these, each of the key within this, right? Enumerate them. That's all I have done here, right? And then print this and this. So that's all it does. With this enumerate, it literally runs through everything and prints them out for you, which is what we have here. And notice it's unordered because you would have expected that Stephen will come first, but it doesn't. Ken comes first. Reason, because dictionaries are unordered collections. So these are other methods which you can try out for yourself, or at least go online, look at typical examples, which now brings us to tuples, right? Like I mentioned, tuples are not one of the three main collection types, like the arrays, sets, and dictionaries. Tuples is a group of different, you can actually use it to store. Notice all the other ones we've done, probably with the exception of dictionary, you can only store one data type. Tuples, you can store different data types. They are generally used to group together multiple values of different types into a single compound value, right? Unlike arrays, sets, and dictionaries, tuples are fixed in size and their elements cannot be added or removed once they are created. Very important. Notice how we used insert, right? And you see another method called remove, to remove elements and all of that. You can't do that with tuple. Once you've put everything there, they are fixed. They're also used for temporary or lightweight data structures and for returning multiple values from a function. Now, literally sometimes they almost behave like functions, right? But then you don't have to create an entire function to do the same thing. So they are like a lightweight version of those data structures when you don't want to create an entire function or method or program. A tuple is one way for you to just like literally put everything on one line. So literally, what this means is they actually occupy the space between dictionaries and other structures. They hold very specific types of data, just like structures, like struct, which we're going to talk about now, but they can be created on the fly like dictionaries. So they are easy to create, but then they are also able to hold different kinds of data, which is something that is typical, which is something you see with structures and maybe classes, right? You know, so they are like, they have intermediate characteristics that fall somewhere between structures and dictionaries. Like dictionaries, you can create them while on the fly. They are commonly used to return multiple values from a function call. Remember when you see most functions, right? You can actually use a function to quickly return. So you have your parameters and you have your arguments. And you can literally use, return different multiple values from a tuple. And this is an example of a tuple right there, where we say we've written this line. I thought I had removed this the last time. Let me go back. Yeah, let me completely remove this. Okay, so this is an example of one of those, right? I've written this. Notice different types of data. This is your typical string. This is an integer. This is a double, and this is another string, right? That's probably a way you could store all of this information about an employee. So it's employee, that's employee here. So I'm saying let this employee equals to this. What am I storing here? I'm storing the employee name. What am I storing next? The age, right? The next thing I'm storing is their salary and then their job title, developer, right? But there's a way I can also store this differently, which is literally store it like a dictionary, right? Where let employee equals to. But you might ask me, like, why is this a tuple and not a dictionary? Notice that a dictionary would have square braces. This is a round brace, and that's how you actually make the specific distinction here. But the good thing is I could say comma and just include one value. I could say 100, right, without it being without it being a dictionary, and it will still be acceptable because tuples accept all kinds of things. So the second type of any questions, by the way? Okay. So the second type of second category of types, right, that we're going to be focusing on now is the user-defined types, which is somewhere around here, right? And the three main ones we're going to talk about right now are classes, structures, and enumerations. One of the things I had mentioned is type, right? You see a lot of things when you do your, go back here, right? All of these are types. Even some of the objects and things you see in life are considered in Swift as types. So you're referring to a person. A person is a type, or maybe a category of, for example, humans, right, is a type. And then there are different, so consider humans, for example, to be a type, right? And then you have about 8 million people, instances of that type. So when I talk about instances, I'm talking about copies, right? Specific, I'm going to use the word instances again. Specific instances of that particular type littered all over the place. You can see all of them have common features, and that's why they are a type. But then when you go down for each of those characteristics, the value of those characteristics could be different. So all humans are instances of a type called human, right? But each of them have a bunch of properties, right? And those properties could be their height, could be their weight, and all of that. But because we are instances, each instance will have a different height, different size, different age, and all of that. So that's how the whole game around type and properties and methods are. So that's why I gave this description or example of a dog, right? In the dog family, right? The dog family is a type, right? But then there are instances of dogs, right? And each of those instances have properties and they have methods. Now, some of their properties could be their breed, their color, their size, their age. For each dog, those characteristics or those properties could be different. And then they also have methods, which are things, instances within that type category do. It's something that's unique to them. like barking, like howling, like wagging their tails, like a strong sense of smell, walking on four legs. All of those are methods or the behavior of instances within that um, class. So then we talk about classes and structures, right? Classes and structures, which are examples of what we mentioned here. Classes and structures, they are user-defined types. You are literally creating this yourself. I already mentioned and discussed the issue of properties. One of the things, right, about properties is they actually provide a way to associate the values with specific structure, class, or enumerations, right? That's what properties. So what do I mean by that? Let me see if I can see an example. Okay, let me use this as an example. So imagine these two properties. Name is a property, score is a property, right? And I explicitly define this name to be a string. Let's say what I have here is Stephen. Stephen is the value, right? The score, Stephen would have made 100, for example. So what this says is properties, right? They provide these properties, name and score. So all of this provides a way to associate the values, these values with this class. Notice that this is a class, open bracket, close bracket, and within it is we've defined the properties. So properties create a way to associate these values to this class. That's the point I was trying to make. I go back here. So these are properties. Now I will assign values to each of these properties. Now this property as a whole provides a connection to this class, which is dog. It helps me associate that instance of dog to the dog class. That's what properties do. It's a constant or variable defined inside a class or struct. They are called properties. So methods, already talked about that. Methods are like they provide a way to access or modify the instant properties. So eventually when I have a class like this, first thing I'm going to do is define the properties, and after that I'm going to define, that's why you have the dot dot dot. The next set of things I'm going to define are the methods, because classes as a type, right, have properties and methods. Now, what methods do is to help manipulate these values, by which their manipulation of these values helps introduce intelligence into this class. Yeah. So they provide functionality related to the instances purpose. I already mentioned to us what an instance is, which is a particular manifestation or a particular instance of that particular of the particular what would you call it now, of the type. So this is an example of a class, right? So you have the class, and then you have, this is your property, and then you have methods, right? So this is typically what a type is. A type has properties, and then it has methods. And then all the methods are doing here is they are receiving these properties, and they are manipulating the properties to be able to achieve an aim. So if I create a particular property, I can receive that property and then use this function to be able to do something with those properties. So in Swift, right, structures and classes are complex data types. So because we are zooming in on structures and classes right now. So both of them are complex data types. And the goal for the next few slides will be to demystify structures and classes. And I'm going to be showing us some of those as we go into trying to build the bouncy ball app. Structures and classes are the building block of most programs, and you're going to see that when you go into now, your Xcode, you're always going to see structures and classes. Most often, you're going to see structures. They're used to define properties and methods, like I already showed us, that add functionality to your program. So these are examples of classes and structures. Look at them, they're almost about the same thing, right? Structures, classes. But there are slight differences. Both of them, as it were, have properties and methods. So one way to look at structures or classes is they are blueprints used to create an object, right? Or think of structures and classes, right? Like they are like digital representation of things, right? So if I want to digitally represent or create a model of the physical dog that I have in my house, I could gather all of its properties and gather all of its attributes and store them within a class. So that class becomes a thing, which is that dog, which is why when I create a class, right, I give it a name. Here, I call this our structure or something. So when you create if I was creating a structure for a dog, I would just say struct dog, right? For humans, I'll be like struct humans. And then within it, I would outline the properties of those humans, and then I will outline their behavior. That's literally. So what tends to happen is at the end of the day, if for example, I'm creating a structure, right, or a class for humans, right? I'm going to look at all of the characteristics that is common to all humans, irrespective of your race, and all of that, and I'll put that as properties. And those properties can be 100 different properties. I'll lay them out. So how do humans behave? You're sure one of the things I wouldn't include in the behavior is I wouldn't include barking, because humans don't bark, right? I can include talking, eating, drinking, jumping. All of those are, but by the time I have done all of that, right, guess what? I have created a blueprint, right, for humans. So if I want to gather information about a particular human called Steven, I could now introduce that to create that instant called Steven. I could now come below and make a call to the struct, and then it would impute all of the information about Steven and print that out to me. So it's like a blueprint. So every human, 8 billion of us, right, can all be created with that blueprint. Think of me playing God, right? Anytime I want to create a new human, I just go, I would add a height for it. I will add a weight for that human. I will add a color for that human, and all of that, and then I will just print. But guess what? This is my blueprint for doing all of that. Like a builder, this is the struct, right? It's literally like my printing plan, building plan. So the object now in itself is a tangible or concrete thing you create using the blueprint. When you do a function call, you're creating an object. We also call it an instance, right? But what's the difference? The object created is an instance of the struct or the class. So that object you've created is an instance, a specific instance, because you can have 100 different instances, but what you have created is the object, right? And sometimes objects and instances are used interchangeably. But the truth is that what you actually create is the object, but the instance, right, is usually just used to show a relationship between the class and the object. So think of it almost like, that's not a good description of it, but just think of it like the noun and the verb of something. So a struct type named, for example, student grade. Just a minute. My power. Okay. A struct type named student grade with 3 properties, English, math, and chemistry, is defined below. So we have this. We've created a struct, and that struct is called student grade. And I'm like, let English equals to this, let math equals to this, and let chemistry equals to this. This is supposed to be variable, but it's okay. Change this to variable. So to create instances of the struct, we simply pass initial values of the 3 properties for different structures through the struct, students through the struct. This is an example of what I'm referring to. I've created a struct, student grade. Boom, we have all of this. Let me quickly make this var and val. Okay, and that's so. I have that, right? So, but then I'm trying to create an instance of this. What do? I say let Peter equals to student grade. So I'm trying to get Peter's student grade, and I enter all of this. For John, I enter all of this. For this, I enter all of this, and then it prints this out. And I'm like, print Peter's English grade is this. Peter.English. John's English grade is this, John.English. So when I did this, right, this can actually go pick all of those answers, and then I have this output. So this is what I mentioned about objects and instances. They can actually be used interchangeably, but instance speaks more to the relationship between the class or structure and the object. So in creating a lot of things sometimes, right, people create modes, right? So you create that one mode, and with that mode, you can create different instances. This, for those of you that have been involved in anything mode engineering, you probably would understand this. You can also see this where you create an architectural plan, and you can use that one plan to create different buildings, same kind of buildings, maybe with little variations, maybe in actual values. So, which is also something similar to this, right? I create an architectural plan, and I can create different instances of the value. So your struct, your class, is literally you developing a blueprint with which you can create the objects. So I go back to this. This is an example of a class too, right? Let's say I'm creating a struct called Ferrari, a structure, or what we call the keyword used for it is struct, but that's actually structure. So these are the properties I'm interested in: the color, the door, the year, the fuel consumption, and all of that. And what method am I creating here, right? I'm creating a method called apply break. So I'm creating a method called apply break. Notice its function, right? So that's why I said methods are a type of function, and I'm going to tell us what the difference between a method and a function is, even though a method is primarily a function. So I'm creating this function apply break, right? And then this is what I have here. So once you apply break, all I've instructed it is print applying break, right? So to create these two objects, right, all I need to do is I'll be like Ferrari1, boom, Ferrari, because I'm making a call to this, right? color red, door for yeah, this, blah, blah, blah. Then Ferrari 2, I do the same thing. And then when I print it out, I notice that each of them has their properties and their methods. This guy has properties and methods. You know, the only difference is a few variations, right? Petrol, diesel, red, black, and all of that. But I've used this one blueprint to be able to create, and I can create 1,000 different Ferraris using this one blueprint. In Swift, structures and classes have many things in common. They both define properties to store values, which I already showed there. They define methods to provide functionality, and then they also define initializers to set up their initial state. So typically, a lot of times you have to, you know, initialize, right? You're starting with something, but that would not necessarily be the end of the value. You're just using them as placeholders. So this is not something I would say is something you need to know at this level, but it's important to also know that classes and structures have different, the primary thing about both of them is inheritance, right? That's one of the main things that structures do not have that classes have. And that's something you're going to see in a lot of object-oriented programming and at a higher level. So I'm not going to dabble into this, but the primary difference between both of them is inheritance. And then you have other things like typecasting, deinitializers, and reference counting. I'm not going to dwell on those, but if you're interested, you could actually just go look for materials and read up on those differences. But for the purposes of this class, those distinctions are not they are very germane. So a class is a way of grouping properties and methods into a logical unit that represents a certain kind of thing, which is what I was mentioning before. So you just use them to group the properties and methods so that they represent a thing. And you know what I mean when I say a thing right now, because I talked about the humans, the dogs, and all of that. It's just a category of things. Now, if this logical grouping is not required, then creating a class is unnecessary. So the only reason why you create a class is because you're trying to group these things together and represent, you know, a number of instances that would follow, right? So classes are a chunk of code that represent specific things. Functions are chunks of code that do specific things. So within that class, you have functions, and those functions do, or generally functions I'm looking at, because now I'm beginning to go discuss the differences between functions and methods. That's very important. So within a class, right, you have properties and you have methods, right? So now I'm going to make a distinction between functions and methods. Now, methods are functions. So functions are chunks of code that do specific things. And I've shown us examples of functions all over the place, right? But methods are functions within a class. They're not necessarily just a class. It could be, let me just say, within a type, right? So if you have a function that is within a class, a structure, or whatever kind of type, right? So there are functions within a type that make it possible for specific things, the things that have been created. Remember when I talked about things to be done within a class, right? So the difference between the method and the function is that methods are subordinate within a class or within a thing. Functions are free agents, right? Methods are subordinate within a class. There are functions that are subordinate within a class, so they are restricted to what's happening locally within that class. But functions can relate to every other property outside that class. So this, for example, notice if I were to remove this function and put it outside of this class, right, it will be your regular function. But once I subsume it within these two braces, curly braces, then all of a sudden, it's not just your regular class, your regular function anymore. As you begin to progress in your programming, those things have implications which at this time are also germane. So I'm going to just discuss generally. So methods and functions are sometimes used interchangeably, but they are somewhat different. Now notice Swift uses the same keyword, func, for both methods and functions. I showed us examples of methods, right? Here, notice we're still using func, which is a keyword reserved for functions. So technically they are functions, but just they are unique because they are assigned or attached to specific classes or structures. Now, when a function is associated with a class, a structure, or an enumeration, which I'm going to talk about, it is referred to as a method. That's the point. Once there's an association between a function and a type, then it is referred to as a method. Otherwise, it is simply called a function. Every method is a function. Every single method is a function, but not every function is a method. Let that sink in. Every method is a function, but not every function is a method. So functions are a subclass of functions. So notice what's going on here, right? So these are data types. I gave us an example of data types. So there are two types of functions. Functions that belong to a data type, which we call methods, and functions that do not belong to a data type. We just leave them as functions. This is an example of the syntax for, a method, right? It's subsumed within this structure called person, right? So everything I'm going to do, so when I'm going to create this function, I'm just going to create methods, right, that are unique to person. Right? I can't be creating something like a function for backing because humans don't back. Now, but I can have a regular function that is just floating on its own, right? It's not subsumed within any class, any enumeration. It's not subsumed within any structure. That we refer as function. And you're going to see some of them in some examples as we begin to work. Like functions, methods perform tasks, but they do so only for objects with which they are associated. So methods, right, operate upon or manipulate the properties of objects with which they are associated. So this right here is an example of a method. This is a method inside a struct, right? So this is my property, this is my method. I create an instance here, right? And then all of a sudden, I can print this and I can, that's my method here, right? Because I've created it from that. And then it gives me an output here because it prints applying anti-lock break. But that's just how you would know like a method because it's subsumed within a structure. So the next thing I'm going to talk about is the enumerations, and we are coming close to finishing this so that we can move to the next 704. Yeah. So enumeration. I'm not sure we talked about this yet in any capacity, but so enumeration is it's used to define a list of possible related values. So for example, if I want to restrict my options to just 4 cardinal points, for example, right? So that I don't ever make a mistake of introducing any other things because I know it's just 4 cardinal points, right? Then I'm going to use something like enumeration. Now let's talk of weather, right? Let's say we have just 4 different, weather conditions within a year. We don't have to go create any, or seasons rather, right? I'm locked in with just those 4 seasons. Those are places where you use enum so that you would never end up running into a problem where you mistakenly introduce something that's not part of the grouping that you are trying to make. So that's where you use things like enum. or enumeration. So it's usually a user-defined data type, which is why, in our grouping, you saw the user-defined thing. It's used to define a list of possible related values, and those values, we refer to them as cases. So days of the week is Monday to Sunday. We don't have any other thing, right? So if I want to create an enumeration, right, all I just do is I come with a name, what's the name of my enumeration, and then open and close bracket, and then I use case to be able to define it. So if I want to create a particular instance, I can create an instance that says let casual day, right, colon day equals to Friday. So this would ordinarily be day.friday, but I can actually just remove the day and just leave .friday, and then all of a sudden we are good. So I've assigned this as casual day. I've assigned Friday as casual day. So if I'm writing any, like a particular string, a sentence, and I just go there and I say / open and close bracket, and within it I type casual day, it's just going to write Friday for me there. So the point being that it has to be a fixed, when you have a situation where you have a fixed set of related values, that's when you so at the end of the day, it helps you lock in that set. So it ensures that the value of an instance is one of the defined values. So you can't go outside these instances. It's a fixed set of instances. So this is an example, right? I'm trying to create the seasons. Now, the other thing to point out is there are so many ways to write this, and which is what I showed here. One way you can do the syntax is just say case, and then you name each of the instances. Or you can literally write it this way. Just type in case, and then list each of the instances and separate them by commas. That's also fine. So which takes me to the example. That's what I did here. Enum season. I've named this enumeration season. I've defined the values for the 4 seasons. Now I can create a variable, right? And I say the current season, and I've created this current season, right? The current season will be equals to spring.season.spring. And then if I decide to come type in the current season is, once I type in current season, it's going to print out this for me. The current season is spring. So literally, just like regular variables, when we did our variables, you can actually create an enumeration variable and assign a value to it right in the same sentence. So this is what we did. Because you've already defined, in this case, because you've already defined all of this, right? You can come under and say last season equals to, and the only options it will give you, once you type in seasons and create and type dot, the only options it will give you will be these cases that have been defined, and then you get to choose one. Hopefully we can use enumeration in one of our exercises. So let me see. This is akin to what I just described now. So current season, you type season, last season equals to season. Once you click dot, it will give you these 4 options and you choose one of them. Current season, season dot. It will give you those options and then you choose this. Once you've chosen it, right, it has now saved current season, last season. And anytime you type in your current season or last season, it literally refers to that season. So, okay, I think we are done with this. Those are all, we are done with this. We are going to, I'm going to have, see if anyone has any questions. If you have any questions, I can respond to them. Otherwise, we're going to take like a 10 minutes break and then come and power through the next 40 minutes, focusing on the bouncy ball app. questions? Okay. So I think that would be it for us now. Okay. All right. So I'm going to stop sharing this and let's get back by 7:20. Thank you, everyone.